And friends,
Thank you so much, dear Tulin.
hear you.
Okay,
Thank you.
we're here with Dr. Maria Elena Cianfanelli, astrophysicist. She's from ASI, the Italian Space Agency. Please, Maria Elena, are you here?
Yes, I am. Hi, everybody. I hope you can
Hello,
hear me
dear.
clearly. And
Yes,
just wanted
perfectly.
to say hello with the webcam. I don't know if the connection will stay. I will just try for a few seconds. Where is it? Hi, everybody. Hi. Hope you can hear me
Hello.
clearly. Hi.
Yes, now we can see you and hear you perfectly. Thank you so much.
Oh, you're
We
so
have the-
nice. Hi, guys. Wait. Hi, guys. I see Risco Cristina. Class? Yes. Yes, so sweet. Then I can see also there was another class with all the beautiful masks on. I cannot see now, but they were from Greece, I suppose. So hi to you too, even if now that you are hidden. So I will switch off the cam so we have more bandwidth to be quicker with the presentation, okay?
Thank you so much, Maria Elena.
Okay.
Thank you for your kindness, for accepting to join this webinar, for preparing a beautiful presentation. Thank you so much for everything.
You're very welcome. I'm very, very happy to be able to be with you today. And I really hope I will give you some nice information. And please, if you have any question, feel free to ask. I will have the chat open all the time. So if you prefer not to ask with the microphone or just write, please feel free. Otherwise, you can use your microphones and ask me, okay? Anytime you can interrupt me and ask me. Okay? Hope the silence is a yes. Okay. And as you asked me so many beautiful questions, I thought that maybe instead of starting with the ordinary presentation, we could start from your questions so that you will give the contribution to this little event in first person. And Monica told me that some of you would like to read the questions. So whenever you see a slide with your question upcoming, you can easily raise your hand and take the microphone, open the microphone and ask it yourself. I will pause just for a few seconds before every question so you have the freedom to talk, okay?
Dear Maria Elena, maybe we can do that. Tulin's students are ready to read the questions. So when a slide comes and they see the question, they can read themselves because
Yes.
they are older students and they are ready to read well.
Oh,
maybe
very
we
good.
have other younger students who are not able to read all the questions.
Okay, perfect. I will start and then you will just take the, how do you say, the drive when it's your time, okay? Now I will share my screen. Let's see, whole screen, share. Oh. Okay, just a second. Okay, can you see it?
Yes, yes, thank you so
Cool,
much.
very cool. So let's start this little journey. You got 16 questions, so it was quite fun for me to answer to them all. I hope answers will be good for you. Please tell me if I speak too fast or too slow, or if you have any preference for understanding the presentation better, okay? Anytime. Okay, so I go. First question. Who reads it? Is anybody going to read it?
Here are our questions, dear doctor. Our first question is, what should we do with space jam?
No, you should take it from the presentation because I I grouped them so that I can have all the questions about one single subject together. Otherwise, it would have been possible for me to make it. So as you can see from the presentation, the first one is, what is a moon village? Can you see the slides? Can you see the presentation?
Please, the student who is reading the questions should read on the slide itself. So number one, written in light blue.
What is a moon village?
Thank you. Okay, so it's from Poland. So thank you. The moon village is a concept. Oh, well, I will, as we have a lot of material today, I will try to be a little quicker and read when I can. So we will have time for all your questions, okay? And if I find that we are very quick, I will stop and also talk myself over giving more informations. I hope it's fine for you. So the Moon Village is a concept proposed by European Space Agency for an international lunar base where scientists and astronauts could live and conduct research. It might include habitats, labs, and systems to produce water and food. At the moment, we are working on the Artemis mission. I'm sure you have heard it because it's so famous. Artemis Multipurpose Habitat Module, MPH, you can see it on the right. It's the first design we have. It's a residence and permanent laboratory for the exploration of the moon and preparation for future missions to Mars, because our aim is to go from Moon to Mars in a very short time. It will be located at the lunar South Pole and must operate for 10 years, hosting astronauts and experiments. It will be like a sort of small camping tent on our satellite. It must survive at the lunar nights and the challenging thermal and radiative environment of the moon. On the left, you can see a little progression of what should be Artemis mission. Obviously, being a mission that is very complex, it's going to be rescheduled and reorganized along time. So it has already have many changes. But the idea and the concept and the scope are always the same: to go on the moon, put a sort of little colony there, make experiment and try to raise and grow food there and see what happens so that we can go to Mars. Now the second question, who can read it?
How could a moon base work?
Thank you, Ludovica. She's from Italy. So there are many aspects that need to be assessed to have a moon base working on the moon. The first, obviously, is energy. We need solar panels or small nuclear reactors to grant constant flux of energy that can be stored, and so that astronauts can also face emergencies and sudden problems that can always happen. As in any case, as in any home, you can have like something going down, something breaking. So you have to have a reservoir of energy, and solar panels and nuclear reactors could be a good strategy with batteries that can store and provide energy. Second problem is water, obviously, because we are made like for the majority of our body mass by water, so we need it. And we cannot bring it there because it would be too pricey to go from Earth to the moon with only water. So we have to extract it from ice in polar craters that we know contain ice. And then food. We should grow in hydroponic greenhouses. It has been experimented that lunar soil could be, if mixed with earthling soil, be useful to grow vegetables. Just a little experiments have been made so far, but they're very promising.
Ma stați mai un pic să văd de dincolo copilașii.
Please, Alina, close your microphone.
Hai să vedem dacă reușesc aici, să mă pun aici. Copilașii.
Hello, everyone.
Here.
Sorry, we cannot hear Maria Elena. Dear partners, please close your microphones. We can't hear from Maria Elena Cianfanelli. Dear Alina, may you please turn your microphone off?
Dar oare de ce în cealaltă copilașii?
Can you hear me now?
Yes, now we can
Okay.
hear you. Yes, we lost your voice.
Okay, because you turned off all the microphones. Good, good. Don't worry. We will get on from here. Okay? Can you hear me now clearly?
Yes, yes, perfectly. Thank
And
you.
can you see the presentation too?
Yes, yes.
Perfect.
Thank you.
Let's go on. So I will read the questions because I think from Turkey maybe there is some issues with the microphone. So, does the moon have seasons? Which is a very good question. The answer is no, because the moon's axis is tilted only by 1.5 grades, while Earth's axis is tilted by 23.5 grades. And without this tilt, there are no seasonal changes. And on the right, you can see the explanation of that. As you can see, sun's rays are hitting Earth differently on the seasons, depending on December, March, June, September. And so you have cooler or warmer periods and more hours of light or less hours of light, depending on how tilted Earth axis is toward the sun. So as the moon has just a very tiny little tilt, there's actually no difference. And so moon doesn't have seasons. Next question, which is from the same school, so I suppose I will read it, is what would happen if the moon didn't exist? And this is another very nice question too. We would have weaker sides, so that will affect ocean life, and weaker sides because tides are caused by the moon gravitational attraction. So it's like if Earth is like in a sort of bulge of water, as you know. Submerged sides of Earth, so the continents, just a very tiny little portion of our surface. Majority of the surface is occupied by the sea. So as it says, if we live in a sort of blob of bowl of water, and inside of it we rotate. And the ball of water is not totally round, it's a little deformed by moon's attraction. And so we would experience weaker tides and shortest days because the moon slows Earth's rotation. We will get again on this concept later. For now, just let's say that if we have a quicker rotation, obviously we would have slower duration for each day. And wild climate swings because Earth axis would wobble, causing ice ages. That's because the attraction of the moon stabilizes a little what is a spontaneous motion of Earth axis that wobbles a little, like when you try to make something spin very much, it doesn't exactly spin on the axis just has a little precession around its vertical axis because you're not so exact in the spin. And that's something like what happened to the Earth. It started rotating, but the spinner was not so precise in spinning, so it wobbles a little. 5 questions. Anybody from Italy? School Vicentini della Porta? Sorry. No? Okay, I will. Oh, here you are. Please. Please, go on.
Allora, parla una persona.
Noi siamo delle chiarimenti.
Yes, you should please read the question quickly, thanks.
Yes.
Una domanda?
Vai. Che domanda?
Per favore, dovreste leggere velocemente la domanda, così andiamo avanti.
Questo. Is it true that the moon is moving away from the Earth more and more every year?
Thank you very much. Yes, it is true. The moon is slowly moving away from Earth. Every year, the moon gets a little farther, about 4 centimeters. It's about the length of your, half of your finger probably. So this happens because of the way the moon's gravity pulls on Earth and affects the ocean. So as the moon moves away, Earth's rotation slows down. the pull between Earth and Moon causes Earth to spin more slowly and the Moon's orbit to grow. It's a sort of skater effect. The Earth extends her arms as a skater and so slows down the balance. It is called angular momentum conservation. If you think Earth and the Moon as an isolated system that have a rotation quantity that is called angular momentum, but for now you don't need to know it exactly, you for sure can imagine it as Earth is the body and Moon are the hands. So as far as you have the hands close to your body, as you can see in the gift you see of the flying skater, the turning will be very quick. But if you extend the arms as she does landing and before jumping, the rotation slows a lot. And so the Moon being so distant and getting a little further slows a little Earth rotation. So we have about 23 and something minutes hours each day, and as far as the Moon goes farther due to the rotation effect, as you know, if you take a rope and put a weight at the end and take the other hand and spin, the object at the end of the rope will try to go away, and that's what the Moon does. And so it gets a little farther every day, and with this sort of skater effect. I think I hope I cleared the concept, but if it's not clear, tell me, I will try to explain it better. So now, question number 6. Oh, it's from the same school of Turkey that we had before. Well, if you can take the microphone, we would be happy to hear from you.
Why is Moon red? Do planets change colors?
Thank you very much. Okay, so it is due to what is called Rayleigh scattering. It's a kind of scattering, which means it has to do with the particles that arrives on Earth's atmosphere from the sun and how they interact, particles and photons, and how they interact with the atmosphere to get what we see. When sunlight passes through Earth's atmosphere from nitrogen and oxygen scattering, shorter wavelengths like blue you can see on the left here, that is higher, it means it has a bigger percentage of scattering, which means that radiation with this length, under 450 nanometers, are scattered a lot, means they are dispersed into the atmosphere, okay? Are scattered more than longer wavelengths, like red. You see, red is lower here. It means the red goes straight into the atmosphere. A blood moon, like this one, happens during a total lunar eclipse when the sun, earth, and moon align in that order. Like this, you have sun, earth, and the moon. So the earth has this amount of atmosphere and this amount of atmosphere to filter sun's radiation, and moon has no direct illumination from the sun. So what you see is the exact result of the filtering of sun radiation by Earth's atmosphere, and it is red. That's because Earth's atmosphere scatters blue light, as we said, allowing longer red wavelengths to reach the moon and reflects off its surface. This effect is similar to why sunsets appear red. They don't appear as red as the red moon because we are only filtered by one side of the atmosphere, see, not both. So the sun comes here, when it's daylight, you have this amount of atmosphere. But when it's sunset or sunrise, especially sunset, the sun is low on the horizon of this person. And so the radiation travels through all this amount of atmosphere. So it's scattered a lot. And so especially the red light comes through and we have those beautiful sunsets. Okay, I will go on. Let's see. Oh, from Greece. Who reads the question? Anybody from Ilion?
Why is Mars is red and Neptune is blue?
Thank you very much. Sorry, I forgot. I put 2 question marks because we have two planets, so I put them twice. Okay. So that's because of their structure. Mars looks red because its surface is covered with iron dioxide, the same thing that makes us rust on Earth. Have you ever taken like a piece of rusted iron, for example? It is reddish. That's the same exact mineral that we have on Mars. Over time, iron in Mars rocks reacted with oxygen in the air and a tiny amount of water which is present, creating a rusty dust that spreads everywhere. It's like a little subtle sand that you have all over the planet and can be easily lifted up by storms. The planet's thin atmosphere lets sunlight scatter this dust, making the whole ground appear red or pinkish, because Mars has an atmosphere, much like Earth, but it's very, very thin. So the amount of energy that arrives to the surface to make projects quick, make reactions quicker, sorry, is bigger than what we have on Earth. So everything is sort of spinned up from a chemical point of view. Neptune appears blue because of methane gas in its atmosphere. Sunlight contains all color, as we know, but methane absorbs all the red light and scatters the blue light back into space, make the planets look blue. So I'm sure you already know how colors and radiation works. If you see an object, for example, red, you have like a red box. It means that the radiation that arrives to the object is all absorbed, but in the red length, in the red frequencies. And that's why they are scattered back to you and you see it red. So it actually means that the object is of any color but red, because it absorbs, or it is of all the radiation it absorbs, which is not red, but it actually looks red. And that's exactly what happens to Neptune. Neptune absorbs any frequency but blue and reflects blue towards us, and so it looks blue. It is because of methane gas. But a very recent study by 2024, last year, showed that this color that was firstly believed to be Neptune true color maybe should be wrong. And this instead very, very fainted light blue, more similar to the greenish color of Uranus, is more correct. That's because those images were overcompensated due to the lack of precision of the cameras we used at the time, like many years ago. It's early Voyager 2, so it's a very long time ago that we took those images. And so we are now waiting for further confirmations about this, because this is probably more correct. These instead are some images by Mars, taken by rovers on Mars. This is natural color, which is this, which was unprocessed images color, which means that it is what the camera took from the planet and delivered to us. And we processed it so that we could deliver an image that would be as if our eyes would be on Mars looking at the surface, because this has the sensitivity of the sensor of the camera, which is different from our human eyes. Instead, this is how a human would look like, would see like on a Mars surface. And this instead, I don't know why my cursor has disappeared. Anyway, and the last one on the right instead is white balanced. It means supposing at least one piece of that rock has a white reflection, how would the colors be balancing everything to that white? And that is what we would see. So whenever one will go on Mars, we will find the real solution to understand which is a very exact color. But anyway, all of them are reddish. So the red is for sure always confirmed. And now we have two questions together, because I tried to give you a comprehensive answer. So if you want to ask me and ask everybody, please feel free. 8 and 9.
Is there life on other planets? Are there any other living species beside us?
Thank you. Thank you from Turkey. Anybody from Romania? Maybe not. Okay, I will read it for you. Is it possible to know the lifespan of an alien? What might happen to him when he dies? Those are very beautiful questions, and actually I asked them myself. But unfortunately, scientists don't know for sure yet. There's a good chance that life exists somewhere in the space, but we have not actually detected at the moment. Tiny microbes like bacteria might live on Mars or in the oceans of icy moons like Europa. Outside of the solar system, thousands of planets orbit distant stars, and some could have the right conditions for life. So far, we haven't found any proof of aliens, smart or simple, but telescopes and space missions keep searching. That's because all of us space curious people that work in space or studied space subjects, we are also curious about that. So we keep on doing missions, trying to find aliens, trying to communicate. We even sent like a little piece of gold with solar system coordinates, a little drawing of our human bodies to give a hint, a recorded music, so that maybe you can listen to that and think that there is life in these little planets. Who knows what will come from that? With so many planets in the universe, many experts think we are probably not alone. And I personally believe there is for sure life somewhere else. But it is not obvious. It is in a form we could easily recognize, because we know life for what we imagine it. But who knows how life could be? Already on Earth, we have quite curious kinds of life. For example, we have endolytes. As you can see here, those are bacteria that get confined by geological movements inside rocks and survive for years and years and years. And those kind of bacteria are something that we are really cherishing to find on Mars, because as you probably know, once it was still full of water. There were streams and rivers on Mars. There was water, so who knows if there was life, and maybe some of that went inside some rocks and waited there for us to be discovered. Who knows? And also on Earth, we have some life examples that are really stunning and very complex if compared with other kind of life on Earth. For example, water bears. They're called tardigrades. Tardigrada is the Latin name. Tardigrades are so cool. First of all, they look like little water bears. Fluffy cheek, all those little arms, chubby body, so nice. And they are incredible. First, they have different sizes, from 0.3 millimeters to 0.5 millimeters to even 0.7 millimeters, which means is about millimeters, which means you can detect it by naked eyes if you're really, really careful. They usually live in watery areas, and for sure we all have had some tardigrades on us in some time. And if you have a microscope, you could find them quite easily. You can go in like water ponds or anywhere like that and try to put water under the microscope, and maybe you will be lucky enough to find them. They are so amazing. They can survive to extreme environments, to until 150 degrees of heat. Like if you put them in the oven with the cake you're baking, they will survive, no problem. They will come out just fine. They will survive in space, open space, where there is no particles. It's empty. You have no oxygens. You have like no elements to get attached to be helped to build yourself or keep yourself. They will survive because they substitute all the atoms that have to do with oxygen with other atoms. They become a sort of little statue. And then when they get back in contact with oxygens, they will start to metabolize it and go back to their ordinary form. They're really amazing. They can stand high pressures, very cold temperatures, which are usually present on other planets, on comets, because in space you have very big thermal excursions by the day and the night. They can stand radiation, which is very present in space, and they can also freeze up to 10 years, which means that virtually, if we take a rock with some tardigrades on and throw it to space for 10 years, and they travel and arrive to another planet or arrive in another planetary system, they could colonize another world because they have that strong resilience. The only important thing is that when they land, they find something they can rely on to rehydrate themselves and start back living. So we have to be very careful because, for example, in Europa, we have probably oceans under the crust, and so we have not to contaminate Europa with our material, with our earth bacteria and beings. Otherwise, we could interfere with the development of its system. Okay, I just went a little off subject, sorry. So let's go on. Oh, another couple of, sorry, I did twice the same because I wanted to add this. Well, sorry, I should have added it before. Anyway, I just put here, how do you say, a number of names and kinds of bacteria that survive already on Earth to very extreme conditions. For example, acidophilus. They thrive in very acidic environments with a pH below 3. We live at the pH about 5.5. Our body is about 5.4, 5.5, and so at 3 we would have been died immediately. They instead thrive. They are happy with that. Also, we have alkalophilus, which means that they thrive in basic environments with a pH above 9. Maybe we can use those kind of substances, I don't know, to clean very dirty places or to erode something we have to take off from, I don't know, a wall or a car. But we should use gloves and masks to protect us because we would be so sensitive to that chemical substances. Instead, they are very happy with that. And then we have anaerobes that live without oxygens, halophils that live in very, very salty areas, hyperthermophilus that can live up to 8,000 Celsius degrees, and so on. I will not read them all because we don't have time, but I kindly invite you to have a look at them because they are so amazing and make you really think that life is certainly somewhere else in the universe. Okay, question number 10. We change subject and start to speak about astronauts. I'm missing an S, sorry, but it's astronauts. Anybody wants to read? No?
How can
Okay.
move an astronaut in space?
Thank you, Alexandros Mokias from Greece, I suppose. Okay, so there I took just 5 points about that, and I also have a little movie for you. It's a few minutes. So first I will go through them and then we can see the little video. So first thing is Newton's third law, obviously. Astronauts move in space by pushing against objects, like the spacecraft or a handtail, because every action has an equal and opposite reaction. As you obviously know, if you have a friend and you push him in a certain way, he will push you back. You will feel a force pushing you away from your friend. That's because you are applying a force, and that force has been similarly applied to you. It's Newton's third law. Then we have jet thrusters. Some spacesuits have small jet thrusters that release bursts of gas, propelling the astronaut forward without needing to push off anything. This is very important because in case astronauts have any problem or need to be quicker or need to ease the maneuvers, those little thrusters just put them in the right direction. Handles and tethers. Spacecrafts have handles and ropes, tethers are called tethers, that astronauts grip or attached to their suits, helping them move safely without floating away. It's a sort of the same principle. I don't know if you've ever been on the mountains. If you have different passages, you will have to, you know, get yourself attached to a rope or to the rocks. And when you move, you have to unchain you from one spot and chain you to another spot, so that you are always somehow linked to survival supply. And it's the same that they do, because it's not unusual that if you are in space, you get a little spin, or a little, you push a little the International Space Station, and you get pushed afar from that. And as the space is empty, you cannot like swim in it and push you back toward the station. So you have to be very, very careful not to get flown away. And sometimes it happens that they use some utensils like hammers or skewers or anything they need. And if they're not very careful, they will be lost in space, because if they only get a very little tiny amount of movement and the astronaut distracts himself or herself, they will fly away and they will never ever be able to take them again. And in fact, there are some utensils going around that has been forgotten from astronauts. So this is just a lead. Oh, sorry, I didn't forget. I didn't finish. Conservation of momentum, we already talked about it. If an astronaut twists an object in one direction, they rotate in the opposite direction. And careful movement, obviously. Since there's no friction in space, small pushes can send astronauts spinning, so they move slowly and deliberately to stay in control. And this little video is about life on the International Space Station, and it's a little extract of some of the activities they have there.